Welcome to Click for Biology. We're looking at ecology. We're looking at ecosystems, and we've discovered that within the ecosystem community, there are populations of different species. And in this video, we're going to give an overview of how you could find the population, estimate the population of a species, and in particular in this video, it would be a species of plant. So we'll use the technique of quadrating, and we can apply this to calculating the population size or estimating the population size of a species, and indeed we could use that to compare two areas. So we may have zone A and zone B, and we have a plant within this area A and B, and we're going to calculate the population for A. We're going to calculate the population for B, and the technique that we will use is that of using quadrats. So let's see how we actually go about doing that. First of all, the word quadrat refers to a square. Now, these squares can be, in fact, be of any size. Typically, when doing ecology fieldwork, your quadrat might be 1 meter by 1 meter. They are sometimes wooden structures, sometimes metal structures, and some people can even use string to make a more flexible model. So the quadrats are used within the sample areas. Here we have sample area A and sample area B. But we have to have a quadrating technique that will allow a careful estimation of population in A and the population in B for comparison. So let's look at how that's actually done. One of the first things that you do for your first location is to set up what's called a random grid coordinated sample. So first of all, let's focus on the grid coordination. So our sample area is shown here in white. And what one would do would be to create a grid system, much as you do on a piece of graph paper, in which we have an x-axis of 1, 2, 3, 4, 5, and 6, and a y-axis of A, B, C, D, E, and F. So we've divided up the total study zone. So in this case, zone A has been divided up into essentially what is a 6 by 6 grid. Now, the next part of this is we're going to select areas in which to actually take our sample. But those samples have to be randomly chosen. You can't just decide that we'll do B1, B2, B3, and B4. Instead, you have to come up with a way of having no bias, of keeping it random. And the way that one does this is to generate using tables of random numbers or random number generator apps. So you would input the size of your sample area and then press the button. And for instance, it might say B2 is your first sample zone. And so we would go to row B, we would go to column 2, and this would be our first sample. And then we're going to count all of the plants which are in here. We repeat that process, so we have what is called a representative sample. So this would, roughly speaking, have to be about 10% of the total area, or if it's a small area, a little bit more than that. So you can see in my sample here, I've actually randomly generated 5 zones, from which to calculate and count the number of plants within those plots. Now, the counting method itself also has to be detailed. So let's say we were counting the common daisy. Here's a picture of one if you don't know them. And in my zone, this is zone A, my first study site, I've split this up into A, B, C, D, and E. And we have 1, 2, 3, 4, 5. That would be my grid system from which I would generate random numbers to select the actual counting area. So then we would place the quadrat at the selective coordinates. You would count every individual of the chosen species. So these are the ones which look yellow in my diagram. You have to apply what are called boundary rules. So let me try and explain this. But before I do that, the boundary rules have to be detailed so that if someone else tries to repeat your population counts, they would do it exactly the same way. This is one of the basic experimental design rules. So I've written some boundary rules here which say you count the daisies in a quadrat. If the daisy is cutting the top line here, you count it. If the daisy is cutting the right-hand edge, then you count it. But if the daisy is on the left-hand edge or the lower edge, we do not count it. So we apply that. Let's take an example to which we could apply. Let's do this grid here. And we can see that for C5, the count looks like it's going to be 1. Now, notice that it's actually cutting the upper boundary, so that's okay because I've written my rules down, so that's okay. If you were cutting one of the under ones, like this one here, if that's our count square here, then this would not be counted because it's cutting the left-hand edge. You can write your own boundary rules, but you must stick to those boundary rules for each of the samples that you take. We record and count the repeats in a representative sample. So I've done that for this particular zone. Here are my quadrats. I made a sample of 5 different quadrats, counted the daisies in my sample area, and they have like so. Now the quadrat area is 1 meter square, but my total habitat that I had is actually 200 meters square. The first thing I do is calculate the average number of daisies per quadrat. So we have 8 plus 11 plus 9 plus 12 plus 10, and then divide that by 5 to give us 10 daisies. This is the average. There are 10 daisies per meter squared. Then what we do is we estimate the population. So our average is 10, but we actually have 200 meters squared. So multiply those two together to give us an estimated population of 2,000 daisies. We would repeat that process for location A and location B, and then we end up with a population here of 2,000 and an estimated population here of 800. And so we have, what we have done here is we have estimated the population, that is the number of individuals of a particular species. And that would be the beginning of an ecology study. What we haven't done is to write a species list, estimate those populations, or even begin to describe the ways in which they interact. So this is just the beginning of any ecological study. Part of your experimental technique requires that the quadrat size needs to be the same. You have to be very careful it's the same species. The number of quadrats should be constant. The method of using those quadrats has to be the same, and the counting rule on the boundaries has to be the same as well. And so here we can walk away knowing that area A has a larger population of daisies than area B. Okay, why not take a few minutes, pause the video, answer the questions, then check the answers in the description below, where you can find the link to the PDF as well. And now we're going to link you through to subscribing to the channel, to the next video in the playlist, and indeed the playlist itself.